This again. This is the third time I've recorded this. I don't know what's going on. So I'm just going to walk through this, and then if you need help, come see me. So on number 10, we start with a white part. Sine theta plus cosine theta over sine theta. Cosine theta minus sine theta over cosine theta. I changed this. This was subtraction. I changed it to addition and pushed the negative through. You have to find common denominators. I only had sine and cosine. Multiply top and bottom by cosine on this first one. Top and bottom by sine on the second one. And then you can get rid of things. So you can see as I push this through, I get cosine times sine, cosine squared. I push the sine through. Negative cosine times sine, positive sine squared. So I ended up with these two being able to cancel out. Cosine squared plus sine squared is a Pythagorean identity. X squared plus y squared equals 1. I can substitute cosine for x, sine for y. And then I can see that cosine squared plus sine squared equals 1. And you can totally leave it like this. I did reciprocals with that, but you don't have to. All right, number 11, they gave me, I'm just going to go back and make sure it's recording because that was super annoying. Okay. They gave me cosine theta was negative square root of 6 over 4, and that I'm in quadrant 2. I'm between 90 and 180. I drew my triangle in quadrant 2. I labeled the adjacent side, which this definitely said negative 6, but negative square root of 6 before I overwrote it with it. So negative square root of 6. And then I used Pythagorean theorem to find this side, and I found that this side was the square root of 10. So I did 4 squared plus negative square root of 6 squared plus b squared. Solved for it. I got this. So now I can plug into my double and half angle formulas. All right, so you can do that from there. All right, 13, it asks where this is equal to 0. So just change the 0 to y equals, graph it on Desmos, and we're only staying between 0 and 2 pi, so make sure you check that out. Desmos automatically is in radian mode, and pick out where it hits the x-axis. All right, I don't know what number this one is. Number 14. Number 14 says you have a right triangle. It has an angle of pi over 14 radian, and one of the legs is 5. I don't know which leg it is, so I drew 2 triangles, and I put 5 on this leg, and then I put 5 on that leg. When I do that, I end up with 2 different triangles, right? I use, on this one, the side opposite is 5 of the angle that I know. So I can use right triangle trig. I don't have to use law of sines. So I used right triangle trig and set this up, and you'll need to solve for x. Right triangle trig and set that up. You'll need to solve for x. It gives me 2 different lengths for the hypotenuse. 15 is law of sines, and so because it's not a right triangle, they're asking me to find this side length. They gave me 1850 for the side AC. They gave me 15 degrees. I can find this angle by 180 minus 25. Then I can add these two together, subtract from 180 to get this one. I need this one because law of sines, I want the angle in its opposite side. So this is the one I'm trying to find, x over sine 15. And then I have this one, so it's 1850 over sine 10. 16, so you can finish that. 16 is law of cosines. So they have a baseball field. We know the distance from home plate to the wall is 403. They want the distance from the wall to third base. When I draw this, it cuts the angle in half, so this is 45. They gave me 90. Hopefully you can see the angle with the 2 sides around it, so that's law of cosines. Number 17, ask me to use a formula, but I need angle C. So use your geometry knowledge. You have 2 of the 3 angles. By the way, when I say use your geometry knowledge, it doesn't mean we haven't talked about it. It means you're probably first introduced in geometry, and if you weren't, that's okay. We've done it, so not a big deal. 180 minus those 2 angles added together, and then you could just plug and chug into the formula. 18, you have to find the area of a non-right triangle and then a rectangle. You can do the rectangle. The non-right triangle, if I have an angle, I can use this one. If I don't have an angle, I use this one. S is the semi-perimeter. So it's been a while since we've done this. So I add A, B, and C together and divide by 3. And that's the S part. A, B, and C are the sides of the triangle. All right, number 21 is the polar one, which seemed to be a bit challenging for some of you, but that's okay. If you need more problems like this, just let me know. I'll make sure this is still recording. Yes, it is. Okay. Whew. All right, so I start with a point, -4 pi over 4. So -4 pi over 4 is right here. Remember, we do the angle first. So I went around 2 pi and then 4 pi and then flipped over the pole. So that is my target point right there. The rest of the questions ask me to rename that point. So when it says r is positive, when r is greater than 0, I know I have to land at this spot. So I have to look at the information that they're giving me about the angle and figure out how to get there. This tells me I have to go in the negative direction. And so to get to that spot, I have to go -180 or negative pi. So you could also write for -180 degrees. I'll take that too. Still trying to land on this spot. I want r to be negative, which means I have to flip over the pole. So I actually need to write it. So I'm landing here with a -4. So I know 4 is negative. So I have -4 and I want to land on this spot. Well, this instruction says it can be 0, but it can't be 2 pi. So it's 0. All right, the next one, keeping in mind I have to land at this spot, and r is positive, so I'm landing right here. So I already know I'm starting with 4, and then I have to be between 360 and 720. It says between 2 pi and 4 pi. So I go around once, and that's 360, and then I need to land here, so that's another 180. 360 plus 180 is 540. So I know this has to be 540 or 3 pi. All right, I'm going to make sure this is still recording. Kind of a little gun shy here. All right, I'm going to keep checking that because it's shut down on me twice. Okay, so actually I'm going to save this and have a part 3.